Um, Hey everyone, in today's video, we're going to see about how your AI model gets trained. So, in previous session in this workshop, we have seen how to actually do the feedback loops and the reward and response things happening. And there are like two more things which is similar to feedback and reward because it is about continuous learning and you give informations on every continuous time like your time series or other anomaly detection, those kind of things. So how it is actually get trained, whether we give input and whenever we feed the feedback it is getting trained. No, it is like every machine learning engineer knows about it. Like they have like clear picture on like our model gets trained. We get input and we put into model, and it does with the any algorithms that is on default. We can just take any linear models on first, and later we can move on to non-linear models, and later we can just train the model with that. From that, we can see whether it is predicting right or giving the response back as expected. Those things we know. So, here I'm going to talk about some of the things that it is basic and raw information that we can learn from this video. So we have Henil here again. We have made a video on our first session, the assignment which I gave for AI agents, like how we can feed the model and get response back from it. So if you are someone who's new, you can just go and check on this video. I'll put the link below. You can check that out. So here, what you will be learning is, as I said, the raw like the back end of your AI model gets trained. So let's get started with the basic code in Python, which I wrote. So this is something, a basic function that we initiate certain things like your learning rate, memory size, experience, performance history, and model state. I'll tell you what is what. Learning rate is your way of teaching your model, like how many times it should learn from it, in what range. That is your learning rate. Memory size is like we need to give a space, right? So it gets learned from that particular range. So that is your memory size. Beyond that, it may overfit, or below that, it may underfit. For that, we are specifying memory size. And experience is your feedback. I mean, how much it understood. That is the experience of the model specifically. So you can just ask about every class of a particular student of after annual exam, how was your experience, right? Like how you wrote your exam. It was like that. So experience is that. And performance history is the statistics. I mean, how much it learned, how well it learned. We can visually see that. So I just added a visualization for it. That is performance history. And model state is we going to add few of the parameters for it to get learned. One is weights, bias. Bias is your error. So how much error we are getting for every training, every learning, how much mistakes it is making. That is your bias. And confidence is your how well the model understood the score for it. So here I mentioned zero point 0.5. Zero point 0.5 above is a positive feedback, like it learned well, like 60 percentage, 70 percentage of not accuracy particularly, it understood that much. Below zero point 0.5 means the model is performing poorly, so we need to improvise. So I just added the confidence level for every learning state. So this is like a basic structure of our model, or the learning phase of our model. So we give input, right? We just ask it to learn what is addition operation in previous session, the first session we say. So we just made it to understand what is addition, but how and how to test the model whether it is understood, whether it is an addition or subtraction, or how to behave for particular range which we gave outside what we trained with. For example, some model won't perform well on a test set, if we train with particular range. I have trained with 1 plus 1 and 1 plus 2, 1 plus 3. So I just given 1 as constant. I mean, for all, 3 rows. When I give 2 plus 2, it won't react if didn't understand. It will say like some wrong answers like 3. 2 plus 2 means 3. If what if it gives like that? So it should understand what is addition operation. So how you will actually train it to do that. So this is the back end of it. Predict function which I included so that we can teach the model on particular value. So as I said, weights is a one where it gets tuned from. So I give a value of input data like 1. The weights we assign for it like on particular range. We can start from 0 to 10. We can just assign weights to it. So we will select a particular row where it got understood a particular operation that it need to trained with. So at what row? Like at ninth row, it understood with a weight of 0.9 or 9. It just understood with zero bias, which means the accuracy is 100% and it understood the operation and gave the exact answer like 1 plus 2 is 3 and 2 plus 2 is 4. So for that, we are giving the weights here, and I have just defined with the input, extend, and the self model state with weights. And we are just subtracting the input data in order to check whether it is giving any error term. So that is how the error is calculated. For example, when I give the output supposed to have is 3, like 1 plus 3 is equal to, let's say, 4 it's supposed to have. So this is the actual data. When I give to the model, it gives me the output of for 1 plus 3 equal to 3 means we have to check with the actual data saying 4 minus 3 equal to 1. So we have error value 1. So it is predicting wrong and the error value is 1. So this is your bias. So we are going back and adjusting the weights in order to get the value 0. I mean 0 bias we need to get. So this is how the calculation works, and this is what I meant as a predicting your entire output. So are we good here?
Yes, yes.
Okay.
Able to understand it till now.
Okay. So here we are adding this feedback, right? So this is a AI model. It learns from feedback. These are like traditional ML way of learning this predict function that it actually compares with your training set, and we can test it with uh, other remaining 20 percentage. The 80-20 percentage, you know, right? So we train the model with 80 percentage and 20 percentage we test it. But in feedback, how we will actually, define and split the data. We don't have such data. We have to do from scratch. So how we expect the model to understand from your, like anything without data. So we have to feed the data and we expect the model to perform well. Like it is impossible, right? So we are receiving in the form of feedback your data that we are receiving in the form of feedback. So model gets trained with it. So we assign positive, negative values, or in reward format, we are like giving scores for every good answers, like positive scores or negative scores. So anything it may be like below 0.5s are bad, above 0.5s are good. So we can specify the reward and feedback scores. That is an our, like that is our end. We can just define that. There is no, like constant or steady way of doing it. But what is the objective is we have to teach the model to learn from it. So that is the objective. So here we are giving some of the things like variables, which is your input, production, feedback score, feedback type, and timestamp. So timestamp is something it may be for your response, like response time, or the moment where it turns, or where it learns. Like when I say how are you at this time, and it responds back at I'm fine. So I'm giving feedback at this time. So it learned that as a previous information. So when I add something new, it learns as a new information. So it appends with that. For that, we are adding timestamp here. And feedback score, we know that we are giving like positive or negative. The feedback type is your positive, negative. Score is the value. So this is the overall function that we name it as a experience, as we defined in a previous parameter. I mean, initiated this parameter previously, and later we are doing this model updation. So here, as I told, we are using a basic linear algorithm. We didn't go for any complicated models like non-linear or neural networks even. We didn't go for that. The linear stuff is fine, like it gets bias. It can understand bias from the error that it is getting responded from the AI model from, and some of the things that we can feed the model, and it fines tune the weights. So everything is there. And the one thing is we have to add the activation function for it. For every output set that we are having, we don't have multiple layers. We just have like input, the processing model, that is your linear model, and your output. For that, we are using activation function here. So whenever there is an misbehaving thing, or not hallucination is not possible because we don't have that much data, but we still do get some wrong answers from the input that we gave. Just because text is more complicated than numbers. This is what the actual fact is, and more complicated is audio or video. Image is also fine, but when we go with the video, we have to make that capture frame by frame actually. So there'll be like lot of data, huge data. So again, we have to convert that into numbers. More than that, audio is like we need to have a transcription for it, or else it is not possible to learn from it. We can have that as an image format. So there are like some other things that we have done previously in my office, which is like we have used wave, I mean audio files, but we converted that, or took that input as an image. So we just took that as an image and converted into numerical format. So this is like a lot of things to do. So anything that you start learning, start with numbers, numerical data, then go with text. Even anything it may be. Even if you are having NLP projects also, start with numbers and go with the NLP. I mean
Okay.
text. Yeah, then slowly progress with that. So update model is one. Whenever there is an error, it tunes and understands from the feedback from it. So we are like giving a condition for it, so that it gets learned from the error term that we give. So I mean that we get.
Okay, so this will be based on text data.
Yes. So we are like converting that straight away to the numerical format. That is,
Really?
yeah.
Okay.
And for that, we are like giving all the scores and confidence level, like thresholds. Those things we are giving the range basically.
Yes, yes.
So these are like primary functions that it have to be there. Next is get performance state. So this is where it is for the logs basically. How actually it is performing. We need to start from scratch. I mean, notice the entire growth of the algorithm, right? For that, I just included this part. So, yeah, this is like saving model, calculate, improve times. These are things which comes under the performance logs, and saving the model, loading. Okay, so these are this like calling the final functions that we call the entire thing. So it gets learned from your positive and negative feedbacks with the scores. And yeah, now let's print and see what all the things that we have in here. Did I add anything? Okay. And I have given the entire thing here, the steps to execute and see, and what all the things that it is included in it. So you don't Can't have to worry about it.
Yeah. Yep. Yep.
Okay. New download. Hmm. Let me execute and see this thing. Feedback AI. Okay. So what we have here is with the default value that I have given to it, it just understood the input, in the name, in the number format, which is just converted that into, and it identifies the response for it. So it predicted with 80 percentage of it. So the feedback is it is giving us a positive. So model prediction with confidence level. So the accuracy is like good. I mean 90 percentage. So it learns for every response that we give to it, the every feedback that we give to it. So whenever you give, it is asking you for any questions or anything. Questions in the sense like it may, how the bot will ask like, hi, how can I help you? And if we give anything and it responds back, that is one set. That is one scenario here. Your scenario one is your one conversation that you make, like a question and reply, question and answers. That is one scenario. So for every scenario, it understands and learns from it. That is your feedback. So when a bot asked me like, how can I help you? When I responded, can you tell me what is LLM? And it responded back with the exact answer. I can give it a positive response. Like it gave me an excellent answer. So that is your feedback. And it gets learned and have that information as it is because it is a positive response. Whenever it is having a negative response, it will come and iterate and do the model again with the information it has. Okay, I gave a wrong answer. For LLM, it gave me some medical terms and some other terms, which is an abbreviation of LLM. And when I gave like it is a very wrong answer, bad response, and a negative score I'm giving, it goes back and learns the information. Okay, this is not the response I supposed to give. So what is the content I have? Like what are the things that I have? And it learns back and gives a response back. So this is the feedback thing which will happen. And for that, we need to follow these steps to train and make it to learn. Yes. And this is your JSON file, which I included. These are the weights. If the model gives me for excellent answers like 90% of accuracy, it gets saved. It gets saved, and with every information that it has, like with confidence level, bias, it had like zero point 0.0, which is like very low. So these are the weights that it used to give me that right answer. So it saved those information. So the response is positive. So for those data that we have here, so it gets saved at what time? So until it gets a new information of for the actual question it asked, it will be the same. If anything new comes, this is a function like update function we saw, right? That will update. So this function will take that and retrain it and update that answer and saves here. So this is how the entire thing works. It is too much, right, for the
Yeah.
review.
I have one question. Can you, if you can explain the inputs? I mean,
Okay.
in detail,
Okay.
what does that
So,
signify?
instead of having text input, I just gave these input as a numerical format directly.
Okay.
So
Okay.
that
So
is why it is very simple to proceed with.
okay.
This one is a test input. Why I didn't include raw text in the sense we can't just go with it. I mean, we have to convert the text.
Into numerical.
Those are simple thing. We can just do that. Henil will take care of that in next session. So he'll use something from scratch, like from the text data and converting into numerical format. Then we can have these things actually, as a bulk of proper AI model. I just wanted to teach the basic step of what it is happening behind. So this is like after the conversion, your numerical data, it may be like A, B, C, D, like that.
Okay.
So I just gave score for everything. Yes.
And in real bots, how we will get these values by converting those textual data into numerical
Oh,
form.
my embed and all, right? Embed encoding, one hot encoding and all there. We'll just convert. Those are terms to convert your text into numerical format. So
Okay.
you will remove stop words, those things. That is like pre-processing step before the entire, the scenarios here I gave, right? So this is what. So for this input, it got like positive response. For this one, it is a negative response. So like that, it gets, learned from it. So I just directly use the, numerical format instead of like going for text, going from text.
Oh, okay,
Yeah.
okay. So these functions that you have written that will remain same, but the
Yeah.
process of taking inputs will change. And and between taking input and feeding those to the functions that you have wrote here, there is a steps which converts those values into numerical stuff. And before that also they remove some words, some stop words, something like that.
So that data cleaning model has to do in order to learn from what I've given. So how are you in the sense I just encoded and encoded the score will be like zero point 0.1, uh, 0.2, 0.3,
0.3.
0.4. So how many? One, 2, 3, 4, and yeah. So this is my converted scores. So I expecting a reply like I'm fine or good. So for this, I'm giving a score of zero point 0.5 or zero point 0.6. So continuation, are you able to uh, noticing? I mean, it may be like similar to that or some other word. If we have like large vocabulary, we can just have that another things like good also. So I'm good. So this is like I'm good with zero point same 5, right? And zero point 0.7 maybe. Depends on the, yeah. So good is a different word. And we have I'm and it is same. So what we can do is it's like, okay. So
So it's like two-way conversion. You feed the text data, and you will get the encoded output. And if you feed encoded output, you will get back the text results.
yes, so it is assigned like it is not just score, it is a unique score which will be assigned for your data alone.
Yep.
There is no, like something which is from outside, it is online and it will be changing every time. No, you gave your data, right? So it will be a unique set of scores that is assigned for your set of data.
Yep.
So it will be like at what time it gave now, like 1920 with a timestamp I'm talking about. A
Oh,
timestamp at this timestamp. So this is like new set of data which it gave at 2030 new timestamp.
correct.
So both are right, but it always finds this one. And whenever I, when I added this information, this also you can give. So it reshuffles and based on the score, I mean the feedback score that we give, it aligns for it. If I'm giving a score for this, like uh, positive, like we have positive range 0 to 5 means I'm giving like 4 positive score for this.
Okay.
For this, I'm giving 3 means it will take this information. Whenever I'm asking, hello, how are you? It always responds with, I'm fine. Because it is large. This is less.
Yes.
These are like very constructed information that it takes and learns because it's a machine, right? We can't expect it to behave like a human and whenever it feels like, oh, okay, I'm not okay, like that and all we say, right? It won't be that. We have to feed that I'm not okay for it.
Okay, okay, got it. Getting it. Like how the very generic chatbot or stuff they are working in the backend.
You have to spoon feed everything. You have to spoon feed every information that you have. I trained one model, like it will talk to me like a superstar. It says all movie dialogues of him from movies.
Having heard like have you been using Instagram? Now they have the AI character stuff. So where you define the characteristics of the AI, like you based on that, it will acquire the nature. And let's say I am making the stuff you said. You made a chatbot who acts in actor. You basically input anything, any characteristic that you want, and it will answer like that.
Yes, yes. So it is like you feeding the information, right? You train like the way you want it. So yeah, this is what it is. So I didn't include this text part. I didn't want to complicate things. This is what it is. I mean, I just wanted to give the actual information instead of like wasting a lot of time on this conversion. People know this stuff. So just giving the back end. Okay. So you do this the complete package of this model uh, in your channel. So you can check those video from Video Geek Net. Already posted one, and the next video will be released soon. So stay tuned,
Yeah, I'll
guys.
try to learn this as ASAP and make video on it.
This is simple. You can do it
Yeah,
like the way you did before.
yeah.
Yeah. So yeah, thanks for watching. Okay, we have one more session this Thursday, and we are winding up this entire workshop. So I hope this video was useful for everyone. Thanks, guys. Thanks for watching. Bye.
Thank you.